going to go over the review for the Unit 8 test, and this is on the segments and lines intersecting circles. So first of all, number 1 says Coach Smith is 6 feet tall and he is standing 10 feet from the stadium, and the flagpole is 85 feet from the stadium. How tall is the flagpole? So I want you to notice here that we have here, and then we have a big triangle right here. So what I'm going to do is to take the side of the little triangle, put it over the side of the big triangle for both. So I notice that I have this 85. So 10 over 85. And then I'm going to compare this side of the little triangle to that. So that's going to be 6 over, so I know what the height is, so we're going to put h on the bottom. So we're going to cross multiply here. We're going to multiply 10 times h, and then we're going to do this, the 85 times 6. When we do that, we get 10h and 10. So h, we're going to divide both sides by the 10, and so h is equal to 51 feet. That's the height of the flagpole. Number 2 says there are two figures. One is a square pyramid. The other is a cube. If the volumes are the same and the height of the cube is 100 feet, how tall is the pyramid? So it's telling us the volumes are the same. So I'm going to compare the volume of a pyramid, which is 1/3 base times height, and then the volume of a cube is really base times height. So this problem tells us that the height of the cube is 100 feet. So I'm going to go 1/3, the volumes are the same, so 1/3 base times height is equal to the base times 100. Well, notice here we got b's on both sides, so that means those can actually cancel each other out, because if we divide one by the other, we would get the same thing. Then we've got here 1/3 base, 1/3 height, my bad. 1/3 h equals 100, and the way that we get rid of a 1/3 is to multiply it by its reciprocal, so we're going to multiply both sides by 3 here. So our height of our cone would have to be 300 feet high for the volumes to stay the same. Number 3 says, given that circle O with a radius of 10 and OC 6, find the length of AB. So it says that the radius is 10 and OB right here is the radius. So I'm going to put my 10 right there. Then it tells me OC, which is right here, is 6. Notice that this is a right triangle right here. So we can use Pythagorean Theorem to solve this. So that's exactly what we're going to do. And I know that this is my hypotenuse because it's opposite the right angle. So I'm going to put my 10 squared here. And then we're going to solve for CB up here. It's asking us for the length of AB, but the only way I can find that is to find CB first. So I'm going to do CB squared plus 6 squared. So CB squared, I'm going to subtract the, well, actually, let me show you this next step, sorry. I'm going to go CB squared plus 36 equals 100. Subtract the 36 from both sides, so CB squared is equal to 64. Take the square root of both sides. So CB is equal to 8. So that's this length right here. Now I know, because that's could be a radius if I kept it going, right? It's going to bisect that angle right there, that chord. So that means this segment from CB to CB and AC are congruent. So that means both of these would have to be 8. So AB is equal to 8 plus 8, which is 16. All right, now number 4 over here says find x. It says that MN is 48, OP is 10, OP is a perpendicular bisector of MN. That means that it bisects that, which means this part right here, over here, has got to be 24. And that part over there would be 24. So I also know that all radii in a circle are congruent, so that means I could draw another one right here. And that one would also be x. That would help me solve for x. So when I do this, I'm again going to use my Pythagorean theorem here. So I'm going to this time say 10 squared, that would be my a squared. Again, we're going to do a squared plus b squared equals c squared. And I know again that this x this time is going to be my c. So I'm going to do 10 squared plus 24 squared, and then that's going to help me figure out what x squared is, and then x ultimately. So what we're going to do is we're going to get 100 here, and we're going to add that to 576. That's going to be my x squared. That's going to give me 676 equals my x squared. Once again, when I want x, I'm going to have to take the square root of both sides. So x is equal to 26 here. All right, number 5. It says if PA is congruent to PB, so PA and PB are congruent, and PA is perpendicular to AO, PB is perpendicular to BO. Those are already labeled here, if you see. Then it says, what do we call PA and PB? Well, first of all, we call them tangents, because those lines are congruent and they're perpendicular to the radii. Then it says PA is 12, so that's 12. That means this down here is 12. It says BO is 5. Well, we know if BO is 5, then AO has to be 5 because they're both radii of the same circle. Then it's asking me to solve for PO. So once again, we're, going to use Pythagorean Theorem. So we're going to use a squared plus b squared, set that equal to our c squared. Let's look where our right angle is. So our right angle is there, so we're actually looking for PO. PO is going to be our c squared. So once again, we're going to say 5 squared plus 12 squared equals PO squared. That's 25 plus 144. That equals PO squared. So that's 169 equals PO squared. Take the square root of both sides. So PO equals 13. That was our answer. All right, now number 6 says MN is, well, first of all, I know that MN, N and O are congruent because they originate, both of those tangents originate from the same point. So I'm going to do 6x plus 2 here for MN and 9x minus 10 right here. Well, because they're congruent, I can set them equal to each other in my equation here, my equality. 9x minus 10. Okay, so I'm going to subtract 6x from both sides. That gives me 3x over here. Going to add 10 to both sides. That gives me 12 here. Going to divide both sides by 3. So x is equal to 4. And it doesn't ask me for x. It asks me for mn. So that means I have to put that back into this equation. 6x plus 2, which means I'm going to do 6 times 4 plus 2, that's 24 plus 2, that's 26. So MN equals 26. With number 7, once again, we have two tangents that are originating from the same point, so we know they're congruent. So we know JK is equal to LK. So we can say 7x minus 12 equals 5x minus 18. Subtract 5x from both sides, we get 2x over here. Oh, by the way, I told you I'll just change that to a plus, I forgot. And then we are going to add 12 to both sides, so that's 30 over there. 2 goes into 30, 15 times. This time we are just solving for x. All right, number 8. When I told you all how to do these types of problems, I told you that when you have two chords that intersect in a circle, our formula is part times part of one chord is equal to part times part of the other chord. Okay, so let's go ahead and label this. It says in the diagram of circle H, chords DF and GE intersect at point H. If GH is 12 and DH is 15 and EH is 10, what's the length of FH? So all we have to do here is multiply part times part here, 12 times 10, and set that equal to 15 times HF, or FH. 15 times FH. So this is going to be 120 is equal to 15 FH. Going to divide both sides by 15. And so FH is equal to 8. All right, number 9. Again, this is the same property, so we've got part times part equals part times part. So once again, I'm going to label these SL 2x minus 2, RL is 9, QL is 6, and PL is 8. So I'm going to multiply this part times that part, 9 times 8, and set that equal to the 6 times our 2x minus 2. 6 times 2x minus 2. So this is going to give us 72 here. It's going to give us 12x minus 12. Going to add 12 to both sides. When we do, that gives us 84. And then we're going to divide both sides by the 12. So that tells us x is equal to 7. Now this time it asks us for LS, which is this length right here. So we got to do LS equals 2 times our 7 minus 2. That's 14 minus 2, that's 12. So that's our answer there. Number 11 says, what is the center of the circle? Well, the circle's inside the triangle, so this center is called an incenter. Then it says, what is AI, BI, and CI? AI is here, it's this one. BI is here, CI is here. Well, it looks to me like these are angle bisectors, because if I look here, I got a tick and a tick, right? So these are angle bisectors. And then it asks us what DI, EI, and FI are. So DI is a radius, EI is a radius, FI is a radius. So these are all radii. So on number 11, it says draw secant ABC. Now on the test, it's not going to tell you to draw, but you're going to need to do this. So I'm going to go ahead and draw a secant and another secant that intersect. It says ABC and AED. So I know this point's got to start out here A. I'm going to call this one B and this one called C. And then I'm going to call this E and this D. Okay. Then it says in circle O. So I'm going to actually put a dot here and call this O. Then it says external point A. Obviously, now we know that's the external point. Sorry about that. I didn't read all the way, just like y'all. So then AB is 4. It says AE is 5. ED is 7. And it wants us to solve for BC. So remember, our formula for this one is, and I'm going to write it up here on top. So this is outside, because these are two secants, times the whole is equal to outside times the whole. Okay? So this is our outside. This whole thing is the whole. Okay? Here again, this is the outside. This whole thing is the whole. So let's go ahead and work this. And do I have room to work this? Let's see if I can. So outside is 4 up here. The whole thing is 4 plus CB. And then I'm going to set that equal to, actually, you know what, y'all, I need some more room. So let me pause this and redraw it. There, now it's a little smaller. So I'm going to again go outside, that's this part right here, times the whole, which is that part together. So I'm going to say times 4 plus BC, and that's equal to the outside down here plus the whole, which is the whole thing down here. So that's 5 plus 7, that's 12. So this is going to be 4 times 4, which is 16, plus 4BC is equal to 60. Going to subtract the 16 from both sides. So this is going to be 4BC is equal to 44. And then divide both sides by 4. So BC is equal to 11. And again, remember, we can check these because 4 times, what is that, 15 is 60. And 5 times 12 is 60. So that was our answer right there. So on number 12, this time it says in the diagram below, secant MNO and SPO intersect outside the circle Q at point O. MN is 18, going to label that. And O is 7, and then it tells us that SO, that's the whole thing, y'all, is 35, okay? So on this one, we're going to do outside here, which is 7, times the whole thing, which means we're going to add the 7 to the 18, and that's going to be 25. And then we're going to do the outside, which is here, which would be OP, or PO, times our whole thing, which is 35. So 7 times 25 is 175. And then we've got 35 PO. So divide both sides by 35. So PO is going to be equal to 5. All right, down here on number 13, it says indicate whether the following statements are true or false. So SU, this is SU, it says they're congruent. SU is congruent to RU is congruent to PU is congruent to QU. Well, that would be a true statement because they're all radii of the circle. Then we have, sorry about that, shouldn't have erased that T. Okay, then we have ST is congruent to QT. That would be true because the diameter RP or the radius RU are bisecting that chord SQ because there's a right angle there, so that's true. Then it says ST, wait, QT, I didn't do that right. ST and TU, nope, I don't know that those are congruent. There's no way for me to know that. Then it says SU squared, that would be a hypotenuse of that right there, yes. Is it equal to ST squared times UT squared? Yes, that's true. Then we've got ST is perpendicular to TU, that's true. Because all 4 of these angles, recall, would be right angles, wouldn't they, y'all? So that's true. And then SQ is perpendicular to RP, that's true as well. And then it says ST times TQ is equal to, so that would be that, and then RT times TP. Yes, because those are 2 chords that intersect inside a circle, so that would also be true. Okay, number 14 says, in the diagram below of circle O, AB is congruent to CD. That means this right here is congruent to this. It also tells me that AB is perpendicular to EO and that CD is perpendicular to FO. Well, that means, because those 2 conditions are true, because the chords are congruent and perpendicular, then we know that they are equidistant from the center. So that means we can say that EO is equal to FO. Then we have equations for EO and FO, so we can say 5x minus 7 is equal to 3x plus 5. So we're going to subtract the 3x from both sides, that gives me 2x. Going to add the 7 to the 5, that's 12. So x is equal to 6. Then it says find the length of EO. And this was the error a lot of my kids made on this test, the quiz, I'm sorry, is they didn't plug the x value back in. So EO was, EO. EO was 5x minus 7. So I'm going to do 5 times 6 minus 7. That's 30 minus 7, so that's 23. That is our answer. So this time, number 15 says, what is the center of this circle called? Well, we see a circle circumscribed about a triangle, so this is a circumcenter. Then it says what term describes HF is right here. Well, look, it's perpendicular and it bisected. And this should have been, sorry, MF right here, y'all. And then KF, again, it was perpendicular and it bisected the segment. So these are perpendicular bisectors, y'all. Perpendicular bisectors. Then it asks us about GF. Oh, that's a radius. Sorry, can't draw straight, but JF, that's a radius, and so is LF. So these are all radii here, y'all, which means they're all congruent. All right, so then we're going to work on this completing the square to find the center and the radius. So when I taught my kids this, I told them to group the x's and the y's in sets of parentheses. So that's what I'm going to start with here. And then we're also going to move this 24 to the other side. So to do that, we would add 24 to both sides. That would make that 24 over there, okay? So we're going to put our x squared in here. We're going to put our 4x in here. And then we're going to put a blank because we're going to fill that in a second. We're going to put a y squared here, and we're going to put a minus 12y here. And again, we're going to put a blank there. So what we're going to do to find what goes in our parentheses down here, because we're going to write the equation of a circle here, is we're going to put an x here and we're going to put a y here. Well, what we're going to do to find that is we're going to take half of this, 4, and that would give us plus 2 here. And then over here, same thing. We're going to take half of that, negative 12, so that's going to be minus 6. Now, to figure out what goes up here in this blank, we're going to square the 2 that's right here. So we're going to square the 2, and that's a 4. Now, if we add something to the left of the equal sign, we have to add something to the right. Here again, with this 6, we're going to square this 6, so that's going to give us 36 up here. And so we're going to add 36 to here. So then we have to add together the 24, the 4, and the 36. Well, 36 plus 4 is 40. 40 plus 24 is 64. Now the question actually asks us to find the center and the radius. Well, our equation for a circle is x minus h squared plus y minus k squared equals r squared. So whatever is in this spot, now notice there's a plus there, so we got to change the sign of that. So our center is going to be a negative 2 because there's a minus in our equation. Over here it's going to be just a 6 because the sign is already negative, so it's going to be positive, okay? And then notice that this right here is equal to r squared. So to find what r is, we have to take the square root of that, right? So r is going to be equal to 8 because the square root of 64 is 8. So now we're on 17. Now when I taught my kids this, I taught them for the top one, which is a secant, we're going to do outside times whole, and then we're going to square the tangent. So what we're going to do for both of these, for 17 and 18, because we have a tangent and we have a secant. So I went ahead and enlarged this a little bit. So it says in the diagram below of circle V, ZW is a tangent, ZXY is a secant, ZY is 18, YX is 6. Those are already labeled in our problem for us. Sometimes you're going to have to label them though. Then it says find ZW in the simplest radical form. So what we're going to do is multiply our outside part here, which is 18, times our whole. Notice that our whole is adding the 18 to the 6, which is 24. And now this time it's going to be equal to our tangent squared. So we're going to say ZW squared. So now when we multiply the 18, so 18 times 34 is 432. This is still equal to ZW squared. So obviously we have to take the square root of both of these sides to get our answer. So we're going to take the square root, of 432, and that's equal to ZW. Now we have to, it says to give this in simplest radical form. So we're going to start factoring this thing. So when we factor 432, I'm going to divide it by 2 first. That gives me 216. Then I'm going to divide that by 2. That gives me 108. Keep dividing it by 2 till I can't anymore. 54. And then 227. Well, I can't divide that anymore. So this is going to now be, so the 27, I'm going to go over here, is going to be 3 and 9, and then 3 and 3. Anytime I see even numbers of numbers, so I see even numbers of this. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 16 right here. And then we have 3 times 3, which is 9. So I want to see what 16 times 9 is. Well, 16 times 9 is 144. guess what? 144 is a perfect square. So I'm going to again go to this 432 right here. And I'm going to say square root of 144. And I'm going to divide 144 into 432. And I'm going to get 3. So I know that this then is 12, because square root of 144 is 12, radical 3. That's going to be my answer, y'all. Okay? Now we're going to do number 18. 18 says in the diagram below circle S, in circle up below of circle S, UV is a tangent to and UXY is a secant. So it says that this is 30 and that UX is 18. So we know that we're going to do the tangent squared, so that's going to be 30 squared is equal to the outside 18 times the outside plus the whole. So remember again, we got to add these two parts together. So it's going to be 18 plus XY. So this is going to be 900 is equal to 324 plus 18XY. Sorry. Subtract the 324 from both sides and we get 576 is equal to 18XY. Remember, that's one term. And then we're going to divide both sides by 18. So XY is equal to 32. All right, here's our last one. The Uber driver only delivers to the radius in the miles shown on the graph. Write an equation for the boundary where the Uber driver delivers by finding its center and radius. Okay, so the center of the circle looks like 1, 2, 3, 4. So negative 4 is our x value. And then down 1, 2, 3, 4, 4. Okay. So that's negative 4, negative 4. And then our radius, count from the center to the circle, 1, 2, 3, 1, 2, 3, 1, 2, 3, so that's 3. So then we're just going to put this in our equation for a circle. Now remember, our circle equation is x minus h squared plus y minus k squared equals r squared, where the center of our circle is h and k, remember? And obviously r is our radius. So we're going to put in here x minus a minus 4, which means it's going to be plus 4 squared, plus y, again, minus a minus 4 will be plus 4 squared. And then we're going to square our r, which means we're going to square the 3. So that's going to be 9. Then it says the driver decides to move, and his new location is a reflection over the x-axis. Okay, so let's figure out where that is. It's a reflection over the x-axis. So this point right now is at negative 4, 4, so it would have to go above. So we're 4 below, we'd have to go 1, 2, 3, 4 above right there. So that would be our new center, right? It says, what is the new equation for the circle? It represents the new boundaries. And I'm going to go ahead and draw this. Its radius is going to be the same, right, y'all? Because it's the same circle. So I'm going to go 3 over, 3 up, 3 to the left, and 3 down. 1, 2, 3. So yeah, I'm going to draw a circle here. It probably won't be too pretty, but I'll try. There we go. So the center of this circle now is going to be negative 4, positive 4. Our radius is still going to be 3. So this time again, we're going to do x minus a minus 4, so that'd be plus 4 squared plus y. This time it is going to be minus 4 because that's a plus 4 squared. And then once again, we're going to square our 3, so that's going to be 9. Then it asks us, are the circles congruent? The answer is yes. Why? Because the radii are equal.